Greetings, everyone. Barry Borman's here, and welcome to the inaugural PHONZ lunchtime seminar. And we're delighted to have two distinguished guests to give the first seminar today. And I'll ask Tim Hopley to give the opening karakia. Tim is there.
Tim, you are there. You're muted though.
Sorry, how's that? Can you hear me now? You can hear me now, Pedro?
Certainly can.
Cool. Kia ora, everybody. Mi karakia tātou. Whakataka tiho ki te uru. Whakataka tihu ki te tonga. Kia makinakina te utu. Kia matari kia tai. Ihu ake ana te aka kuru. Hi tuhoi, hi haka, hi he hu, tehi Māori ora. Tāwhai. Thanks, Patrick. Back to you, Barry.
Thank you, Tim. And as I said, welcome everyone to this, the first PHONZ lunchtime seminar. And as I said, I'm delighted that we've got Gerda, Kuschel and Kylie Mason to give the inaugural lunchtime seminar. So welcome, Gerda and Kylie, and over to you.
Kia ora, thank you for that introduction, Barry. He was supposed to say that it's my birthday in 2 days' time and that I'm an engineer, so that in recognition of my birthday, please, all of you erudite epidemiologists in the audience, go kindly on me, because I am actually a chemical materials engineer, but for some bizarre reason was leading HAPINZ. So on that note, okay, thank you so much for inviting me to speak to this. It's a great privilege to do that. It's also a tremendous privilege to represent the team. This is work done by Mission Impossible and the HAPINZ 3 team, which sounds a bit like a 1980s band, but it was a band of very competent professionals, and I'm the one who gets to present it. So if there's super detailed questions that I cannot answer, I may well direct you to other competent or more competent people on the team than me. So we're talking about HAPINZ here. HAPINZ is a health and air pollution in New Zealand study. This is number 3 because the original one was in 2001. This one is the second iteration, and we've entitled this The Tale of Two Pollutants. So I'll cover some stuff initially, and then Kylie will show you the awesome dashboard that her team's put together. So without further ado, what I'll cover first is, just because I'm not quite sure who's in the audience, I'm sure a bunch of you know heaps about this stuff, but for those of you who don't, I'll just get everybody up to speed with a brief introduction around air pollution, its impacts. I'll summarise some stuff on the methodology. There is a 200-page report for anybody who wants to knock themselves out on that, but I'll summarise what we actually did in this study, particularly different to the other one, around the cohort study led by Simon Hales and Jean Atkinson and others. A brief review of the key findings, and then a discussion of the implications for public health. As I said before, I hand over to Kylie. The intention is that I'll go through slides reasonably quickly. There's not a huge number of them to enable you guys to ask questions, so it's a bit more of a two-way street. So first, a wee bit of background. What's the big deal about clean air? I'm sure most of you are aware that it contributes to New Zealanders' quality of life, not only their health, but the natural functioning and beauty of the natural and physical environments. For Māori, it's a taonga and part of their kaitiangatanga for them. Also, it's very, very significant for the naming of places. Many names, or most names in Māori actually are about what people can see and how they describe their environment. So if you have degraded air quality, people can't see what's in the distance and you lose that connection with the land. Relatively speaking, versus other countries, New Zealand does have good air quality. However, on occasion, exhaust emissions from vehicles in particular and solid fuel emissions, those are from wood and coal used to heat homes in winter, which is now, can combine to produce unacceptable air quality in some locations. And even low levels of air pollution can cause significant adverse effects and a burden to the health system. So hold that thought. So what do we mean by air pollution? Well, it's complicated. It's not just one particular thing. It's actually a complex mixture of particles. And we usually refer to those as particulate matter. And of course, because we're sciencey people, we have to have our own acronym PM and other types of gases. Now, with regards to PM, particulate matter, the size of the PM matters. If it's smaller than 10 microns, it can enter into your airways. So when I take a deep breath in, anything that is smaller than 10 microns can get into my lungs. If it's way smaller than 10 microns, something called PM 2.5, which is 2.5 microns or even smaller, it can get further and further into my respiratory system and even start getting into the bloodstream, which is not helpful if it then carries wee particles to places like the brain. If we're looking at the gases, that is things like nitrogen dioxide and carbon monoxide and things that you would have heard of. In New Zealand, the key pollutants that we worry about is this PM 2.5, you know, that finer fraction of the PM10, the PM10 itself, and NO2, which is nitrogen dioxide. Most of these come from typically anthropogenic sources, which is our human-made sources, especially fuel combustion, but they can also arise from dust-generating activities that are under human control. There are natural sources of some air pollutants, particularly for particulate. We can have sea spray and volcanoes, and even forests can emit volatile organics and other things that contribute to air pollution. We can't do a lot about the natural sources, so most of the time we focus on the anthropogenic, the human-made sources. What are the effects of air pollution? Well, wide-ranging and quite scary. They range from things around increased disease and illness, classified as morbidity, through to premature death around mortality. If we look at the nature of the health effects in terms of the numbers and the severity, we get a classical sort of pyramid-y thing that you see down the bottom, which is taken from the World Health Organization, which basically says we get a lot of low-level effects, and as the effects get more serious, we get fewer of them. So you'll end up with a situation where if there's air pollution exposure, a lot of people might be exposed to feeling unwell. Maybe if they're asthmatics, they need to use increased medication. But as the concentrations build up, the effects get much more serious, but there are fewer case numbers of those. Air pollution ends up all through your body in different ways. It impacts you in different ways. A lot of, for example, around the particulate matter response is believed to be caused by inflammation, that the material just gets into your system and causes inflammation, and inflammation is just not very helpful if it travels to parts of your body that are wanting to be operating and functioning in a good way. So who's most affected by air pollution? Well, unfortunately, the effects of air pollution, like almost any other environmental risk, are not felt evenly in the community. Some people can be much more vulnerable because they're more exposed to the environmental hazards. In the case of air pollution, living near highways and low-lying valleys where the air pollution gets trapped, or industrial areas, they may be more sensitive to the effects. For example, children, elderly, diabetics, asthmatics, and people would be aware that New Zealand has a lot of asthmatics. I'm one of those. People that are less resilient in being able to anticipate or cope or recover from that type of exposure. So if you don't have as much money as somebody else, the choices that you make to try and reduce your own personal exposure are quite limited. So those are things that typically affect people's vulnerability. How do we assess the impacts? Well, we really need to understand, firstly, what is the exposure that people are experiencing, because it's the combination of the length of time that someone's exposed to the air pollutants. Typically, we focus on long-term exposure, annual. It's the concentrations of those pollutants and the sensitivity of the exposed population that combine together to determine what is the likelihood and the magnitude of the resultant health effects. So people's exposure, for example, we need to think about, well, which pollutants are we going to assess? What's the base year? Which sources are we interested in? How can we look at the spatial resolution of that exposure? Do we have the information and monitoring data or populational health to be able to actually look at those things? Then we need to sort of decide, well, which health impacts matter to us? Are we looking at long-term or short-term effects? different age groups of genders, ethnicities, how do we deal with double counting, do we have exposure response functions. If we've got that information combined together, we can then sort of start thinking about social costs. So how do we monetize those in terms of put a value on those things? Do we have a value of statistical life, medical costs, productivity losses, etc.? So there's quite a bit that goes into these assessments. So what did we actually do in HAPINZ 3? Well, there's a team of researchers. As I said, I'm the one that was leading a group of extremely talented individuals, ranging from air quality scientists through to people who were looking at transport modelling. As I mentioned, Kylie's part of the team from Massey University who will look at the health data. Tim Den was from resource economics, Alistair Woodward, Simon Howes and June Atkinson on the cohort study and the epidemiological aspects. And we were particularly fortunate this time around to actually be able to involve Jess Berenson-Shaw and her team at the workshop, who have specialised skills in how to communicate these messages. I think a lot of you probably have heard the results of the HAPINZ 3 study. It's not a happy thing to be telling people about the number of premature deaths. So how do you communicate that information in a way that engages people into action rather than them just feeling hopeless by, oh my goodness, this is just such a big number, what am I going to do? As with all studies, a word from the sponsors. We are very grateful to have received funding from pretty much all the major agencies involved in this. Ministry for the Environment, Te Manatu Waka, Ministry of Transport, Ministry of Health and Waka Kotahi New Zealand Transport Agency all came on board to view this as a whole of government response to the problem of what is the air pollution effects in New Zealand. We also received grateful assistance from the regional councils and unitary authorities to use their monitoring data to be able to sort of put that into our exposure mapping. The base year in spatial resolution, it was 2016. Why 2016? Well, typically we need to average data over 3 years to account for inter-annual variability in meteorology, the weather conditions. Colder years or windier years can change your concentration. So you want to make sure that if you're doing the snapshot in time, which HAPINZ is, you're picking average conditions for that, for your assessment, that it wasn't just a good year or a particularly bad year. So if you want to pick 2016, you need to have 2017 data available, and there's a bit of a lag in getting information together. When we started, it was the best year that we could pick to match the monitoring data, the population data, and the health information. In terms of spatial resolution, we did the assessment at the CAU level, particularly for 2013 census area unit level. Why not SA2 was a question that we got, which is the new statistical area units from Stats New Zealand. That is because a lot of our data wasn't necessarily defined at the SA2 level, so we went with what is the base metric. And then we were able to aggregate that information up to Airshed, Council, District Health Board. In terms of the indicators of exposure, we actually looked at 2. We looked at fine particulate matter less than 2.5 microns, this PM 2.5 stuff, and nitrogen dioxide, NO2. In the previous HAPINZ, Nino Kinsley, for people who may know who he is, leading person on air pollution exposure assessment, our international peer reviewer, said that it would be valuable for us to have a look at nitrogen dioxide because he felt that we possibly had undercooked the impact of transport, famous last words. So we were looking at trying to get more information around nitrogen dioxide with the additional monitoring information that would be available. So for PM 2.5, we had a lot of actual data. I mean, lots of locations, we actually had really good information. So most of the time it was actual data in preference to modelling, and we applied those concentrations typically to entire airsheds and looked at locations that were similar if we could not find specific monitoring data for those locations. Nitrogen dioxide was a bit tricky. We do have a monitoring network called the National Ambient Air Quality Monitoring Network by Waka Kotahi, but that uses things called passive tubes, which are not a reference method for nitrogen dioxide. We have some locations where we actually have monitors, but not very many. So we had to look at modelled estimates generated by Waka Kotahi Vehicle Emissions Mapping Tool, which is a tool that takes together all the roads across New Zealand, not just the state highways, but all the roads, looks at generating the emissions and the subsequent concentrations, and then matches those up with background concentrations developed by NIWA based on their monitoring results. So we created an exposure map across the whole of New Zealand for PM2.5, a comparable one for NO2, but for the NO2 one, we also looked at some select locations to see if the numbers looked reasonable. And so far, everywhere we've looked in detail, it looks pretty good to be able to get our mapping. Source allocation, well, there's two different ways that you do it. For PM2.5, we actually use source apportionment fingerprints, which are kind of like particulate DNA. If you collect particulate samples, which lots of councils do as part of their regulatory monitoring, those samples can then be run through the GNS facility that Perry Davey was our lead person on, to look at elemental fingerprints to say, if I have this combination of elements, they're most likely to represent a domestic fire signal or a motor vehicle signal or an industry signal or windblown dust or sea spray or other things. So we use those elemental fingerprints to actually apportion what we see in the monitoring sites to be able to give us how much comes from domestic fires and motor vehicles, etc. For nitrogen dioxide, we used a different approach because essentially we were using an exposure map across New Zealand generated from the road network. So in this situation, we looked at background NO2 levels from everything, but exposure also from roadways, and said, well, look, what we're going to do in this situation, because we really don't have super great information, is to assign responsibility 100% to motor vehicles, even though we know from emissions inventories in urban environments, it's probably 90%, not necessarily 100%, but that was the best that we could actually do. Those sources that are marked on that slide with a little orange star are considered to be anthropogenic. So those are the ones that we focused on for the health effects reporting, because those are the ones we have the most control over. In terms of the health impacts for mortality, we looked at premature deaths and years of life lost. Much of the focus goes on premature deaths rather than YLLs, years of life lost, but we did do both, and for separated out for PM2.5 and for NO2. For morbidity, we looked at different kinds of hospitalizations, respiratory and cardiovascular, due to both of those two things for all ages, but we also did a subset for asthma wheeze hospitalizations in children aged 0 to 18. We had another metric called restricted activity days, RADs. Those are basically days when air pollution exposure prevents people from being able to go to work or school or do the things that they normally do. So that's at that low level of the pyramid that we spoke about before. And they impact across all ages. A separate morbidity outcome that we also looked at was the prevalence of childhood asthma due to annual NO2 in the 0 to 18 category, again to reflect the New Zealand situation about the concern around the level of asthma in the community. In terms of the health calculations, the calculation to do the number of cases from air pollution is essentially the one that's recommended in the World Health Organization, global burden of disease, the use of the population attributable fraction, multiplied by the total number of cases to give us the cases that we believe are attributed to air pollution. The PAF, for those people who aren't super familiar with it, is basically a function of the exposure response function, which is the relative risk that you get for every increment of air pollution, and what is the level of exposure. So that exposure response function is, as I said, the risk ratio that shows the relative increase in the health effect for every increment of air pollution. So if you have an exposure response function, for example, of 1.105 for every 10 microgram, which is a unit of concentration of annual PM2.5 for a mortality outcome, it basically means the risk of death increases by 10.5% for every 10 microgram increase in that concentration. So it's a relative risk function. So obviously the bigger the ERF is, the worse it is for that particular outcome. And there's the amazing PAF equation for those people who want to knock themselves out. The exposure response functions that we used for everything except for the RADS equation that we used in ASPA prevalence were developed from a cohort study by Hales et al. Published in Science of Total Environment, and that was undertaken specifically for the HAPINZ 3 study for us to get New Zealand exposure response functions. Historically in New Zealand, we've used a lot of those functions from overseas, which don't necessarily reflect the way that our population responds or the concentrations that people are exposed to. The results were rigorously checked using the risk of bias assessment instrument from WHO, and I do have some additional slides I can cover if we have time for questions to go through that, and extensively peer reviewed by Javier Carroll, Michael Holland and Bert Bonacreef. People may be familiar that those are all authors of the World Health Organization's 2021 guideline update. Professor Bonacreef in particular, we were very privileged to have him as an external reviewer because he had essentially done a massive study in Europe on low levels of air pollution, which was most relevant to New Zealand, and so had a lot of expertise. The cost calculations followed on from the air pollution case calculations. You basically then value each of those cases to give you your total costs, a thing we call social costs, which is the cost to society of air pollution. It's not just the cost of medication or the cost of someone being in hospital for a certain number of days. It reflects loss of life quality, time taken out for other people having to look after someone who's unwell, and lost productivity and recovery. For the costs or the valuations per case, the mortality costs were based on the value of statistical life, VOSL, and that's the one that's used in road safety and was 4.5 million more or less per death in New Zealand dollars in June 2019, which was the year that we chose to do the valuations. For the morbidity costs, as I said, we knew how many bed nights there were in hospital for different types of hospitalizations. We had information around medication, so we're able to say, okay, those costs range from $89 a case up to $36,000, $89 more around RADs, $36,000 more around hospitalizations, and then amalgamated those up. So what did we find? Well, what did we find? We found that NO2 was way more significant than we had expected. We found that when we combined, that diagram there shows on the left-hand side the impact of the particles in terms of the number of cases, the PM2.5 stuff, and on the right-hand side, the NO2, which we ascribe to exhaust gas from vehicles. That combining those two things together, about 3,300 New Zealanders died prematurely. This is in 2016 due to human-made, that's anthropogenic air pollution, which represents, for context, 10 times the road toll in that year and more than 10% of all deaths in that year. You can see that a significant, or twice as many come from, of the premature deaths come from NO2 relative to fine particles. And when you consider that all the blue ones basically come from vehicles, we end up in a situation where about 67% of the total costs come from vehicles. Because they have a bit of a contribution on the particle side, but a full contribution on the NO2 side, and about 60% of the costs overall are from NO2. You can see that, again, as I mentioned from the pyramid, we have up the top, say 3,300 deaths, ranging down to 1.745 million restricted activity days, with other things falling in between. We went back and had a look at 2006 because the methodology that we used for HAPINZ 3 was different to what we'd used in HAPINZ 2, and therefore there was value, if you're looking at trends, to go back and repeat what we would have seen as a snapshot for 2006 to 2016. And what we found was that health impacts from air pollution increased since 2006 by about 10% overall, but that was largely driven by NO2, and it was a tale of two pollutants. On the positive side, we saw that for fine particles, the pale orange bar that you'd see on the bottom, the concentrations or population weighted concentrations improved by 21%, but we only got a 9% improvement in the actual costs associated with PM2.5, because between 2006 and 2016, the population had grown. So if you get population growth, you need to actually reduce your emissions a lot more because of the fact you've got that counteracted by the population growth, which is why you don't see 20% there for that. Unfortunately, the converse of that is that for looking at NO2, the concentrations increased by 13% between those two periods of time, and the costs ballooned out by 28%. It's fair to say we did not know when we did HAPINZ 2 quite the extent at which we were going to have some problems with vehicle emissions. And so the focus was very much after HAPINZ 2 on PM 2.5, which is why we've seen that really cool reduction in population weighted PM 2.5 exposure. So the good news is if we're aware we've got a problem and people focus their attentions on that, we do actually see a change and an improvement, which is what you can see in the orange bar reducing between those 2 periods of time. Another thing that we got out of our findings was this thing called damage costs. If you take the total amount of our social costs and then match those to emissions estimates, which we have in most locations across New Zealand, that is the emissions that regional councils and others do for what are the emissions in their regions and where do they come from. We can actually match the social costs to an emissions to get a damage cost, which is $1 per tonne. The reason why that's really helpful is it's very easy when you're looking at mitigation for someone to say, I know that if I take out this many domestic fires, it's going to cost me this much. If you want to compare the benefits, you need to be able to quantify the benefits in a similar language so that you are comparing a Gerda favourite statement, apples with apples rather than apples with hedgehogs. So damage costs enable you to do the apples versus apples, and we were able to look at the impact in urban versus rural environments. Because in an urban environment, 1 tonne of particulate will have quite a difference in terms of its health effects versus 1 tonne in a rural environment. There are loads more people exposed in an urban environment due to population density, whereas in rural environments, you don't get that so much. So there is a difference. So we've got damage costs for urban, rural, and also New Zealand overall. Also reflecting that there's a lot of co-benefits between air quality and climate change options that you have to improve things. We also included the Treasury numbers that are used. They produce for CO2e, which is carbon dioxide equivalents, some shadow prices that can also be used in those assessments so that you can combine that information to give you a more holistic view of what your benefits would truly be from whatever the option is you're looking at. So in that list, as I said, we've got PM 2.5 and NOx, which is basically come out of HAPINZ, and we've used other numbers for SO2, which is sulfur dioxide, VOC, volatile organics, and carbon monoxide, just to round out the full picture of things that come from different sources, and they can be used combined together. The new findings, as I mentioned, was, well, firstly, it was, my goodness, we're in New Zealand with low levels of air pollution. These are really big numbers, deaths. So low levels of air pollution cause significant harm. As I mentioned, the contribution of motor vehicles was much more significant than we previously thought. We had not been able to quantify the effects of NO2 in the previous studies due to insufficient information. And it's fairly true that when we got the results coming out of the cohort study, we were like, oh my goodness, this can't be right. I mean, it's just so big. And we went through extensive review of those numbers to make sure it wasn't to do with model bias. It wasn't to do with something we got wrong with the exposure mapping. It wasn't a whole pile of things that you can look at. And trust me, we looked at absolutely all of them over quite a long period of time to make sure that they were actually real. So the effects of NO2 are real. And if you're drilling down that little bit extra, where do they most likely come from? Well, if we look at the motor vehicle fleet, the diesel vehicles are disproportionate emitters of NO2, particularly heavy diesel vehicles, and they dominate the emissions that we look at for NO2 health effects. So as I said, what changed since HAPINZ 2? Well, HAPINZ 3, we developed exposure response functions for New Zealand for PM 2.5 and NO2, and we used what's called a 2-pollutant model. A lot of the stuff previously done in New Zealand was using a single pollutant model. And so what that actually means is we used in HAPINZ 2 PM10 as a proxy for all air pollution. So we said, well, we don't have good monitoring data for everything. We've got really good monitoring data for PM10. We will assume that we use PM10 as a proxy for everything. Not a bad decision, totally fine at the time with the state of knowledge that we actually knew. But what that means is you've only got one contaminant that you can actually use to explain what you might be seeing in terms of the change in health effects in different locations. And where it becomes a particular problem is if you then say, okay, we know that this is PM10 as a proxy for all air pollution, and now we're going to say the impact that we're seeing is due to vehicles and domestic fires based on their ratio of PM10, but we find that that isn't true, which is what's happened now. So if you use PM10 as a proxy for air pollution, but the sources that you have are contributing in different ways, that's where it becomes a wee problem, which is what we found in HAPINZ 3, and now why motor vehicles have become much higher in everyone's awareness than previously. One cool thing about two pollutant models, however, is if they're done in a way where we show that it's truly independent, we can combine the effects of those things together and they become additive. And typically, if you have multi-pollutant models with truly independent things, the exposure response functions become much tighter in terms of their confidence intervals. Just to again, just explain that, for example, if you were looking at a single pollutant model for PM 2.5 to explain air pollution effects across the whole of New Zealand, you might end up with a relatively high risk factor of, say, 1.205. So for every 10 micrograms of PM 2.5, there'd be a 20% increase in health effects, and you'd have wide confidence intervals. But if you then say, okay, I want to explain what I'm seeing in terms of my change of health effects with two independent parameters, then what we found, and this is from the HAPINZ experience, that the risk factor for PM 2.5 drops because we can now look at PM 2.5 and NO2 separately. And so it drops the quantum or the size of our risk factor, as well as narrowing the confidence intervals. And because it's based on two pollutants, the effects are additive. So looking at our new risk factors, for example, the top two lines associated with the multi-pollutant model, the two pollutant models, that's what we're seeing. So you can see with 2.5 and NO2, the risk factors are quite similar. They're both about 10% for every 10 microgram increase. If we were to look at a single pollutant model on PM10 only, it's also around about 10%. But in reality, our PM10 concentrations are about twice what we see for PM 2.5 and NO2, which is why it still ends up giving us roughly the same number. Just to emphasize, in New Zealand, our population weighted for what we did for HAPINZ in 2016, annual PM 2.5 is 6.5 micrograms per cubic metre. That's not very big. Similarly, the 2016 annual NO2 is 7.8. These are not high numbers relative to other jurisdictions. Which brings me to my next slide. As I mentioned, when we did our work, we were quite uncomfortable initially because our numbers seemed so high, because we were one of the first researchers, particularly Simon's paper at the time in Science for Total Environment, was one of the first to show such big impacts, because lots of jurisdictions had actually been looking at NO2 levels that were a lot higher than what we see in New Zealand. And we now suspect that what we're seeing is that the graph is what we call supralinear. So what it means is the exposure response curve bends over. So if you're at low levels, you get a massive change with small concentrations. But as you get to higher and higher levels, if your population's exposed to really high levels like 40, 50, 100 micrograms per cubic metre of annual average NO2, they're already at a high level. It isn't going to get that much worse because it's already really bad, but it's not going to get that much worse in terms of incremental change. Hot off the press as of about a week ago, the Health Effects Institute in the States released a State of Global Air Initiative looking at NO2, now identifying that NO2 is a really big issue. They looked at a range of cities across the world, and for once in our lives, New Zealand is actually there. You can see Auckland. Often we just somehow New Zealand disappears off these global maps, but for once we're actually there, and there's even a dot for Auckland. So using a more generic methodology, they looked at a number of cities across the world. The dots there indicate where their levels, as I said, are really high. And they found that 86% of the cities they looked at had now exceed the World Health Organization's 10 microgram per cubic metre annual average guideline. As I said, we're sitting at 7.8 in New Zealand. So that's at least 2.6 billion people exposed. The interesting thing they found is that while PM 2.5 exposures tended to be higher in low to middle income countries because people are using biomass burning for heating their homes or other things, the NO2 exposure actually was high in high income as well. And that's probably because in high to middle income countries, we can afford to buy motor vehicles. Everybody kind of has to heat their home or you do cooking. And in high income countries, we've also got that discretion around how many vehicles that we might have. So as I said, looking at that map there, even with Auckland in theory being one of the sort of pale blue dots, we're still talking about, from the HAPINZ study, significant numbers of deaths from NO2 from our estimates. So what does this mean for managing public health impacts from air pollution? Well, there's bad news and there's good news. The bad news is low levels of air pollution can cause significant harm. Okay, we've shown that, it's not great. Funnily enough, the good news is that low levels of air pollution can cause significant harm. The reason why I say that that is good news is because small reductions in air pollution therefore can mean it's big benefits. If we're talking about things like climate change, we're often talking about reducing things by 50% or 60%. What we're saying for air pollution in this situation is if we could even achieve a 5% reduction on our 2016 levels or exposure, we'd reduce premature deaths by, or we estimate we reduce premature deaths by, nearly over 180, hospitalizations by 720, asthma hospitalizations in children by 36, and restricted activity days by more than 138,000. So it means it's not so scary when it comes to looking at how you can actually manage this, and therefore every little bit that you can do is going to make a difference. As I mentioned, effects are not experienced evenly. Looking at the new World Health Organization guidelines that came out last year and looking at what we found from HAPINZ, there's over 80% of New Zealanders are living in areas where annual PM2.5 is above the guideline now, which is 5. We find that the proportion is slightly lower amongst Māori, but much higher amongst Pacific peoples. If we look at the bulk of the Māori population, a lot of them are rural areas where the concentrations are not so high. For the Pacific peoples, it appears that they're more congregated around cities, particularly like Auckland, in much closer proximity to where the emissions are being released. So these differences reflect the differences in where those different populations live. The situation is not too different for NO2, although it's not 80%, it's still over 30% living in areas with annual NO2 above the new guideline level. It's worth saying here, we all expected in the air quality community that the WHO 2021 guidelines, when they came out, would be lower than what they had been in the past. But never in my wildest dreams did I imagine that they would go from a World Health Organization guideline of 40 down to 10. That's a 75% reduction. That is absolutely huge, but it is reflecting the new evidence that's coming up saying, look, at low levels, this is a problem. And it really puts the focus squarely on wanting to do some more monitoring in this area. Again, looking at Māori and Pacifica, the proportions lower in Māori and higher in the Pacifica, again, where they live. And you can see in that graph there, it's much more variable for the regions. If I just skim back to the previous one, there wasn't as much variability necessarily in this graph if we're looking at the regions across New Zealand with those bars for PM2.5, but if we look at NO2, it's quite varied as to what you see for that. So what can be done for PM2.5? People are opting for cleaner burner appliances. That's why we've seen a change in the population weighted PM2.5. Go us for those people who've been able to move to cleaner appliances. But it needs to happen faster than the rate at which the population's growing and aging. As people age, their susceptibility to air pollution isn't great. So we need to be aware that that's happening, not just in terms of the numbers, but the response of that population. We need to be looking at non-exhaust PM from vehicles. And by that, I mean when vehicles travel on a road, they generate tyre and brake dust. They also generate road dust. Those things are not going to change or go away if we turn those vehicles from internal combustion engines into EVs. So non-exhaust PM is going to be around for a while. So we need to just keep an eye on that because it will stay there and it still has an impact on low levels. As I mentioned, the new World Health Organization guideline is much tighter than it was in the past. It's 5 now versus 10, reflecting that new evidence. And with the 2.5 stuff, the damage costs, we've got one of those for 2.5. So we can look at our options and have an intelligent conversation about what's actually going to make a difference, particularly maybe, or not maybe, hopefully, focusing on those communities of more exposure where you've got the inequities. What can we do for NO2? It's kind of similar. Vehicles are getting cleaner, but as with wood burners, the shift needs to happen much faster than the rate at which both the population, which is us, and also our fleet is growing and aging. We have one of the oldest average fleet ages in the world at 14.1 average years. So the average vehicle going around is 14.1 years, which means 50% of them are older than that. And we hold on to them for a very long time. And at the moment, it just every year they get older and older. So we need to be looking at the fleet age. That isn't helping because you can't take advantage of the new emission standards, the population. So we really need to be focusing strongly on that now that we know we've got a problem. As I mentioned, WHO guidelines much tighter, 75% improvement. And again, we have damage costs. So that means cool things. We can actually look at apples versus apples for a range of transport options. In terms of the tools that can help you guys, if you're looking at, well, what does it mean for me and the work that I do as a public health professional, there is a truckload of stuff out there. I never thought I'd be responsible for a study that had so much material that you can actually use. We have the Volume 1 report, which is basically the key findings and the implications. The Volume 2 has the detailed methodology about how we got to that space. We have a short guide from the workshop about how can you talk about this to your communities or stakeholders or people that you interact with to try and turn the messaging around into positive things around action. We have, for people who really like playing with models, we have a health effects model complete with a user guide that tells you how to use it, that can drill down on what it means for your location, and it has a scenario tool available that enables you to tweak things, going, what happens if my population gets a bit older, it gets more of them, or we change these concentrations. So you can play with that quite happily. Of probably more interest or more relevance to a lot of you that you'd be familiar with seeing it is we've got an interactive dashboard, which is very similar to all the other dashboards that are on the HAPINZ site. Kylie will go through how that works, but this is just super cool visualization of the key stuff that we get from the results and some of the key drivers. So I'll stop talking about that at the moment, otherwise I'll steal Kylie's wonderful thunder. So pretty much just to sum up, we've got opportunities actually to maximise the co-benefits. As I mentioned, there is a lot happening in the space at the moment, particularly around climate change initiatives and particularly around transport. So there's a range of things that have been released in response to the Climate Change Commission saying that we need to do something. There's an emissions reduction plan with different little tasks around increased PT, which is public transport, walking and cycling, loads of things to address vehicles' greenhouse gas emissions. And many of these will and can deliver air quality benefits. And those in particular that encourage more walking and cycling have an opportunity to deliver what I'm calling a trifecta of co-benefits. If we're intelligent about the options that we've actually got to address things and look at things with an evidence base, which we now have with the HAPINZ information, we've got loads of information about greenhouse gases, and also around walking and cycling, we can do something that not only improves the air quality to reduce those adverse effects, reduces the greenhouse gas emissions, and also increases the activity level of the population. With the costs that we have for air quality and greenhouse gases, there are costs currently in the Waka Kotahi monetised benefits and cost manual around every kilometre that a person walks. For example, there's a $4 benefit from their increased activity and not leading so much of a sedentary lifestyle. So you can start bolting on the health effects from that or health benefits from that to the air quality and climate change benefit stuff we've done in HAPINZ. You can even look at noise stuff as well to get a more holistic view of the public health benefits that you can actually get from your particular initiative and start having a really good conversation. So it's a pretty exciting time to be in this space with all the various tools. So at that point, I think it's kind of probably helpful if I stop sharing my screen and Kylie does a quick 5-minute demo or more on the interactive dashboard, and then we should have enough time left over to do some questions. So fingers and toes crossed I can find my mouse, stop sharing, and hand over to the lovely Kylie.
Okay, so I'll just share my screen as well. I'm just going to quickly go through the tools that you have available if you want to explore the HAPINZ data in more detail. There's 2 ways to get to the dashboard. Firstly, on the Ministry for the Environment webpage, there's a publication page for HAPINZ, and if you scroll down, there's an infographic, and if you download the infographic, there's a link on it. If you want to go through the HAPINZ website, so we are hosting information about HAPINZ, and you go through project HAPINZ 3, and then there's a lot of information available here from the study. All the publications and data are available as well that you can get here, but there's also a link to the dashboard. I'll just load that up now. And so this dashboard has the data available at the territorial authority level, and it's got a really wide breadth of information so that you can investigate basically what you want to. So I'll just quickly run through what it has so that you can see. So here you've got in the left-hand box, we've got information about the study and just what's covered. Here's a map of New Zealand with all the territorial authorities, and it's showing indicator that we've chosen over in this drop-down menu. Now, there's the darker the colour on the map, the higher the value, and they've done it as quintiles, so we have about equal numbers of territorial authorities in each category. And so you can select the indicator that you're interested in from these boxes. Start from the top one. So we've got health impacts from human-made air pollution, but we also have health impacts by source of air pollution, and that includes motor vehicles and domestic fires. Other sources were quite small contributions once you get down to TA level, so we haven't included them here. You can also look at exposure to poor air quality in terms of against the WHO standards for NO2 and also for PM2.5, and also factors influencing air quality. So that includes likes of wood burners, coal burners, and hopefully one day we might be able to stick some motor vehicle data up. So here we'll look at the health impacts from human-made air pollution. We've got premature deaths among people aged 30 years and over. That's what we looked at in the HAPINZ study. Here in this drop down, you can look at the particular pollutant that you're interested in. We'll just look at the overall ones. Now here at the moment, we're looking at the number of deaths. You can also look at the rate. So if we look at this map, we can see that some areas that have a higher number of deaths caused from human-made air pollution. And the highest one is actually Auckland. Now, I can tell that partly from hovering over, and you'll see that it highlights the Auckland region in the different boxes. But I can also use this graph on the bottom to show me if I hover over, it'll tell me what one has the highest value. So Auckland, followed by Christchurch and Dunedin. And we also have a table of all the results out to the right-hand side. If you want to sort them, we can click on the heading number of deaths. So we can sort from lowest to highest, or click again, we can get from highest to lowest. Now, of course, we would probably expect that the highest number of deaths is going to be from the Auckland region because it's got the highest number of people. So it can be quite interesting to look at the rate per 100,000 people, so accounting for population size. Just to know, for premature deaths, because mortality was only looked at among people aged 30 and over, the rate is also among the population aged 30 and over. But this gives quite a different picture. So Auckland here, you can see on the bottom, click on it, we can see that it's about sort of around the middle, slightly lower than the New Zealand average, which is the red line. And instead, some of the higher areas are Invercargill, Christchurch City, Waitaki, Nauru, Masterton. And if we look over in the table, we can see the counts as well. So some of them are based on quite small counts. So I think it's useful to be aware of both the absolute numbers and also the relative impact per head of population. And Gerda mentioned that we looked at 2006 results as well. So you can also look at that in the graph on the left-hand bottom side. You can also choose to look at data in the drop-down menu. And I think I will, one last thing, if you want to go to the HAPINZ website, the EHI version, you can click on the left-hand button. If you want to download the data, there's two ways of doing it. You can go to the table of the data that you want, click on this little, what is it? I think it might be that. If I unselect Auckland, so I can click on this download and it will give me the values that you can basically import as a CSV file. Also, we've made the data available in an Excel spreadsheet, and that has data at the PA level, but also at the district health board or district level, airsheds, regional council, and Auckland local community board level. And so just click on download data and you can download that Excel file. And I will stop there so that there's time for questions.
Thanks, Kylie, and thanks, Gerda. There is obviously the sign of a good presentation, and an interesting topic is the number of questions that do come in. And there is a number on the chat and both in the Q&A. Gerda, you can see those, and Kylie.
No, I can't actually. I'm just going to go and have, I'm going to have a look at the Q&A. Okay.
Okay, I'll read it.
Okay, I've got the first one. Yep. Why is the damage cost for New Zealand much lower compared to the damage cost for urban area and not an average of the damage cost? Okay. Okay, so basically that question is why, when I showed the thing that said urban areas 1 tonne of particulates a big deal, whereas in rural areas not so much because of the people that are exposed. It's basically the ratio of urban and rural areas across New Zealand means the New Zealand average sort of looks like that, I think, because it's dominated by the fact that when we're looking at across the whole of New Zealand, it comes out that way. So I think I may have answered that one kind of okay. What are the non-exhaust sources of PM? I think I covered that during my talk, but I'll just reiterate it. When we look at burning fuel out of the back end of a car, that's when we get fine particulate matter. It's usually superfine combustion particles. But when vehicles travel down the road, their tyres and wear against the roads, you get the particles of the tyres come off, but you also get road wear, and you also get, when you apply your brakes, those sort of fragment and also create dust. If the road that you're traveling on is unsealed, you also get dust emissions from that as well. So I think that's cool. What is the relative impact of emissions from planes? We didn't usually, for what we were looking at, the impact of planes on harmful emissions would not necessarily be super high when they're actually flying around in the sky, because of the fact that their emissions are emitted usually 30,000 feet. So it's usually miles away from where people are. There are emissions from planes at airports where you get particularly large amounts of NO2 when the plane is trying to take off. Relative to what we've seen from vehicles, it's a much lower proportion, but those kinds of things would be really helpful for us to know 100% sure if we do the more detailed exposure mapping that we'd feel a bit more comfortable with as part of our recommendations for future work. Did you include health impacts from preterm birth from NO2? I'm not quite sure I understand what is mentioned by that question in terms of the health impacts from. We only looked at the health effects for particular age categories. One of our earlier HAPINZ, we actually looked at deaths in wee babies from particulate matter, but we didn't include that in this particular version of HAPINZ. So I'm not sure that that was a health outcome. I'm pretty sure that's not a health outcome that we actually were able to look at. And I should mention that because we picked the study, was only taking data up to 2017, effects from COVID itself, which make people more susceptible, have poor outcomes, and also the fact that lockdowns reduced NO2 levels was not considered in what we were looking at. So long-term complications due to chronic disease. No, I don't think we looked specifically at, because in order for preterm birth from that, we'd need to have known the exposure where people actually were at that particular time. So I don't think we covered that, unless Kylie's got an answer to that. Nope.
Gerda, there's one in the chat. Can you hear a person interested in SO2 given the high prevalence of domestic coal burning in the southern parts of the southern region?
Right. So the issue with SO2 is it wouldn't have been picked up as much from what we were doing, and that the SO2 signal is more likely to be a function of the PM 2.5 that we pick up. Because if you are using coal burning or a lot of older wood burners, coal will give you the SO2, but the SO2 signal will actually appear in your particulate because it actually reacts in the atmosphere and forms secondary particulate. So we would pick up some of the coal burning from places like Invercargill and Southland areas, which are still with a reasonably high prevalence of coal burning. So that would appear in the PM 2.5 signal, but not able to be teased out from a national level that we're looking at for HAPINZ. I am aware that at the moment, unfortunately, because of Kylie's wonderful dashboard, Invercargill just went right up there as the worst on a per population basis for particular categories. And I know that Environment Southland is specifically looking at their makeup of emissions sources to try and get a better handle on that coal burning aspect. So that's that one.
Alex Jones said, did you look at how many New Zealand deaths, diseases and or cost you would save a year from switching from gas vehicle to electric vehicle?
The short answer to that question is yes. We're actually in the process of doing that at the moment. The other thing that we haven't done that I didn't mention is we've done some prelim work for 2019 because, as I said, we realised that we're in 2022 now, and 2016 seems like a million years ago. Our preliminary estimates say that between 2016 and 2019, NO2 and PM2.5 have improved. So we think that we've actually improved the health effects by 2.4%, even with population increasing over that time. We created a 2019 model specifically to try and look at, or we're still doing it at the moment, looking at what you can do with what's been identified in the emissions reduction plan. The Ministry of Transport has identified a whole range of these cool initiatives for climate change, and we're looking at each of those, saying how would those, or how could those be structured in such a way to contribute to a better health outcome. And one of those is specifically looking at the difference between a fully electrified fleet and internal combustion engines and when those things come in. So what I'd say is yes, but we haven't quite published the results yet. So watch the space, and hopefully there'll be something coming in that fairly soon.
Good. And there is one other, and I think this one is actually for Kylie, from our colleague actually at the EPA who's done work on air pollution. Great presentation, which we all agree. Is the dashboard calculating health impacts on the fly, or were the calculations done before and then added to the dashboard?
Yeah, so Gerda mentioned that we could get the estimates at different geographic levels just by aggregating up from the CAU level. And so all that calculation that was done before adding final data to the dashboard. I think it would take too long to computationally be calculating it on the fly. Yep.
Okay, thanks Kylie. And Gerda, you've got one more. Did the study include emissions from cruise ships?
Again, sort of yes, sort of, because we were looking at particulate data near ports, which pick up, I mean, we wouldn't necessarily be able to pull out just a cruise ship. We were able, when I mentioned about the source fingerprints around PM2.5, one of the source fingerprints is actually for shipping. Shipping actually produces vanadium from their fuel oils and bits and pieces that they have in the thing. So if we see vanadium, then we go, whoa, there must be ships somewhere nearby there. And so the answer is yes, it's included where we had monitoring sites near those locations, but we have looked specifically at the port emissions for other work we've done for the Ministry of Health. There's a transport risks report that I did that's available on the ESR website, looking at what the relative risks are of the different sources. Again, on a national scale, we wouldn't expect it to be very big. There are concerns around cruise ships in terms of the emissions that they release in sensitive ecosystems because of vegetative effects from those things. There's concern around cruise ships around how much fuel they use. And certainly pre-MARPOL, because there's a thing called the MARPOL, which is the rule that will change the amount of sulfur that those vessels are allowed to be having in their fuel. And if you reduce the sulfur content of fuels, that typically, well, it takes away the SO2, which is not great. I mean, SO2 is not good for you. It also reduces the PM2.5 and so improves those things going down as well. So the answer is yes, it's in there. Can we pull it out easily? Not so much at the moment, but we can have a look at that in more detail on a CAU basis rather than when we're amalgamating up, as Kylie said, at an airshed or a district health board level.
Okay, thank you. And time for one last question. Alex Jones, I think it's only, can you unmute yourself, please?
Oh, yes, sorry. So I was just going to ask if you knew, with how you're talking about how most of it's from vehicles, if you knew what proportion is from like personal vehicles versus what proportion is from like transporting goods like food and animals and woods and furniture and things like that.
That's a really good question. The answer is we kind of sort of can, because we look at the fleet as a whole. We have some really good information. There's a thing called the New Zealand Fleet Statistics, and it has all the registered vehicles. And when we look at where the emissions contributions come from, we know how much, for example, is coming from light petrol vehicles, light diesel vehicles, electric vehicles, light commercial vehicles, which is like little utes and vans, heavy trucks, etc. So you can kind of break that down. And that's pretty much, I think, at the moment what the Ministry of Transport is looking at for their emissions reduction plan stuff, and what we're also looking at to meet those particular targets or aims of their program, because they've got some specific things saying we want to reduce the amount of vehicle kilometres travelled by personal cars. One of our initiatives is looking at it for trucks, making those things more efficient. We can actually, from our models, there's a thing called the vehicle emissions prediction model, we can look at what the relative emissions of those things are and actually tease that out. So it is being looked at as part of that other study at the moment.
Thank you.
Thank
There seems to be no more questions, and I can't think of a better way to start the PHONZ seminar.
Sorry, Barry, we do have one more
We
question
do.
from Tom Scott.
Tom, okay.
Yeah, I'm just interested in what, or if anything's been looked at in terms of the contribution of diesel trains. One of the reasons why I'm interested in that is we've actually got a cycle trail that runs parallel to and very close to a reasonably heavily used railway line that runs diesel, as I say, there's diesel trains on it.
Again, great question. Thank you for that one, Tom. And good for you for wanting to be cycling in the wilderness, but not necessarily being exposed to diesel train emissions. Yeah, one of the other things that we're looking at in the future is, again, because we've been focusing on largely motor vehicles, but we do know that there are a whole lot of other things making up the whole called domestic transport picture, is looking at developing a comparable model for trains. If we're thinking about trains, it's kind of, again, a bit like two stories, like HAPINZ is PM 2.5 and NO2. If we look at trains, it's public transport versus freight. Most locations are going, public transport is trying to go fully electric by 2025. So we're seeing that for passenger trains, which people probably come into the contact with more than other normal trains, those are being electrified. Well, that's really great, because again, that's that urban rural thing. In a rural environment, that's where you will see diesel locomotives, particularly in the South Island, because there is no electrification. There's more electrification in the north than the south. So it's not the same picture. We are looking at developing a companion model to the vehicle emissions prediction model that I spoke about before, which gives us our really good emission factors for the different sectors. I think that was Alex's question. We're looking at doing something similar for trains to then get a better picture of those things. It's fair to say that most of the time when people are exposed to bad levels, if we're doing a comparable assessment, a roadway with heavy trucks, you'd get way more material coming out of those trucks, because there's just way more trucks traveling every hour relative to how often you would see a locomotive on some of those trails. But that doesn't mean that there isn't an impact. It doesn't mean that it isn't unpleasant. We haven't quite got that nailed in terms of understanding those locomotives just yet. I would say the risk off the cuff is very low, because you're in those environments, usually in the wilderness, where your air pollution gets dispersed anyway. It will be unpleasant, but it will be probably transitory. Whereas in an urban environment, you've got corridors where the trucks and everything are going all the time. So we need to look at those. Does that help?
Yeah, it does. This is actually an urban environment. It's basically runs from Dunedin to Port Chalmers along railway line.
Oh, okay. Cool. In which, well,
Yeah.
in that case, the rail model that we're talking about would be very helpful to look at that particular situation. And again, it's the frequency of those things. There is another study being released called the Domestic Transport Costs and Charges Project, which actually looks at the different modes that might be helpful as well. You can probably email me, Tom, if you want links to those if you can't find them.
Yep. Okay.
Okay, well, thanks very much, Gerda and Kylie, for an excellent initial PHONZ webinar. I must admit that I didn't know there could be so much enthusiasm exhibited about air pollution, but you certainly, both of you, exhibited that today. So a wonderful study, and thank you very much. And I'd also like to thank everybody participating in the webinar. And I should also say that there will be another one at the end of September. So once again, thank you very much.
Sorry, but Barry, just one thing. I'm quite happy to give you a PDF version of my slides that you can put on the PHONZ website if you want for people to refer to.
Okay, we'd appreciate that. Thank you very much.
Cool.
Good.
Thank
So,
you.
good afternoon, everyone. Thank you.